So this is part of the paleo-environmental part of this module, starting now, and that I'm mostly delivering with some input from Chris on the practical side. And so you've hopefully discussed about how oceanic circulation works and atmospheric circulation with Chris, and about modelling. I think you already done a session on atmospheric oceanic modelling or climate modelling. So this is kind of going to hopefully make more sense of your practical that you started with us earlier in the term, or at least you'll already be experts in this stuff, so we can whiz through it. So the paleo, marine and terrestrial sediments section of the course, which is what this is, aims to do these two things. Look at a range of different sediments for paleoclimatic reconstruction, which you've already been doing in your project, or your first practical. Examine the principal climate proxies that derive from such sediments. So particularly we're looking at what the sediments can tell us, what those different types of, when you were downloading your data sets for your first practical, what some of those things are and what they can tell us. So I'm going to introduce you to that, and then later in the session point you to where you can find out more. So hopefully by the end you have some idea of major ways that we can use paleoclimate data to derive from marine and terrestrial sediment archives, or what we can find out from marine and terrestrial sediment archives basically, and work out some of the problems and values of that. I think the first one you'll actually get more from your reading than from this lecture. This lecture is more sort of introducing you to key points, explain things like oxygen isotopes, a little bit of the history of how some of these proxies were used, what proxies mean, and go through some basic concepts which a lot of you will be familiar with either from geology, physical geography before you came to uni, or earth system science, and just remind you of some sort of basic geological principles that relate to this. So there's a lot of different sessions to this today, allegedly 4 hours. Tomorrow 2 hours, then again next week 4 hours as well. So this is all for this to cover marine and terrestrial part, or sort of 1/3 of the module. But these 4-hour sessions are totally mad. None of us can cope with being in here for 4 hours. And I don't think it's very useful over time. So we're going to, it's more likely to be today, it's more likely to be about 2 hours. And then I'll explain to you about where you can, what reading you can access and where you can find out more information about this kind of stuff. And then on Wednesday, another lecture which will lead on from this one. And I'd like you to do some reading yourselves for this time next week. So I expect about an hour or so of lecture, and then an hour or so of discussion of papers, and I'll explain that in a minute. This, I don't think we're going to use this, but we'll see how things go. Mostly these 4-hour sessions just allow us to do the practicals, and so it doesn't have classes in your timetables. This is here. To remind you, actually this Thursday you're supposed to send us your formative assessment, which is your group report. You don't have to write individual reports of the data analysis practical you're doing so far. And what we really wanted you to get out of that was presenting your data that you downloaded in a form that is clear, so making usable and readable graph, explaining what that data set shows, or what the patterns are, how there's variation over the cores that you're looking at, or the data record that you're looking at, and making some observations about where there might be some similarities or differences and what those might be. You might find no similarities whatsoever, or you might find that they totally match the record, and explaining why that might be. A lot of the point of it was to get you to realise that the sort of data that we can access is kind of, has been averaged already, has already been processed somewhat, so it's taking data from say 5 centimetre bit of a core and then putting one number on it, so it's not actually, it's already gone through some sort of a data processing before you get the numbers, and that the data sets are not like perfect. So trying to work out how to deal with these imperfect data sets. Also part of it is to get you an opportunity to practice again and again, like you're probably doing key skills as well, how to present your data and how to, just to remind you about how to write a sort of linking report from data collection and data analysis to explaining what that data means, interpreting it. But it's not a really, really big thing. It's just 2 sides out 4. It's just to see how you get on, really, and to help lead into this. And we think that in past years it's helped. So this looks like an awful lot of stuff. The bit you really need to remember is, well, email us please your group report, or what you have so far, if you have some deadline, or deadline that clashes with it. And here, 2 papers that I want you to read. So I would like you to read, well, actually 1 paper, but I'd like, can I just designate the papers so that what we do, because when I did this before, I said pick one of these 2 papers, so 90–80% of the class pick one, and 2%, which is like half a person or something or less, pick the other one, and then there's nothing to talk about. So could I just say sort of right in the middle of you 2, and up between there, that's that water bottle. Everybody on this side of the room is going to read the first one, the Paleoclimate Proxies Agree, which is Axford et al. And everybody to the left of the water bottle is going to read Massive Iceberg Discharges Are Triggers for Global Climate Change. So it's just 1 paper you need to read for that session, which will be this time next week. And what I want us to just talk about what they show, and bear in mind when you're reading it, if you see sort of any correlations between what you're reading and the issues that you've had with your data analysis practical or material you've read for that practical, because that might help to sort of make the conversation more colourful. And we'll try and talk about what they show and what the challenges that are posed are, because they're saying, this is kind of what your data analysis practical is about. Well, do paleoclimate proxies agree, and do they show the same thing? It's been a good thing. It was sunny at the beach though. And then, what was I saying before I kicked the bucket? Yeah, so this is, sorry? Yeah, so this is related to the data analysis practical. Hopefully, having participated in that is going to actually help discussing that. But so I'd like to discuss the parallels and challenges associated with using proxies, basically, as demonstrated through these 2 papers. And during that time, I'll also go through the papers and try and explain any things that I found challenging, or that I think that you might find challenging, and explaining. So that's the point of that session. Okay, so today I'm basically going to introduce you to climate proxies, go through the basic geological principles that underpin some of these, understanding of how proxies are used. Give a brief introduction to marine and terrestrial records, and then a bit more on marine records. And the next session, on tomorrow, will be looking at terrestrial records. So they basically introduce them first and then give you more detail of both afterwards. Okay, so does anybody know who these guys are? Not all guys.
That's not Darwin on the right, is it?
It is Darwin on the right, yes. Well spotted. Yeah. And this guy, anybody else know who might be really important in our understanding of paleo environment? He's not alive anymore, this is James Hutton. James Hutton was responsible for the idea of, uniformitarianism. Can somebody tell me what uniformitarianism is, other than just the present is the key to the past? Do you know what that means? You've probably encountered it in quite a few different modules, either from me or from other people. Stefan, maybe a question.
Isn't it like, it's like something leading to something else now?
Sorry?
Is it like one thing leading to something else, equals something else? No, I don't know.
Well,
Everything's like...
so one of the things about uniformitarianism is that, somebody's got something. Yeah, it's all right, you can say.
Isn't it just like cause and effect?
No, if you observe it once, it's going to be the same thing. Like,
yeah, so process doesn't change. So processes have never changed in time, and what we can observe now is what has always happened in the past, and those processes have occurred, we can observe them, and that's exactly how it's been before. And also that the rate of change has been gradual, it's been like that all the time. So those are 2 of the parts of uniformitarianism, and other aspects of it as well. But particularly the process not changing, and gradualism, which is this sort of gradual change being important is another key uniformitarianism concept. And it was, I talked about this last time, Henry did hazards. Catastrophism was a sort of counter theory or counter paradigm, and it was it had origins in the idea of the biblical flood, and it got kind of trashed because of the association with religion and that it was deemed non-scientific. So uniformitarianism got better press and became the dominant theory for a long time. But actually, neo-catastrophism or sort of recent ideas about catastrophism have shown that sometimes change does happen in dramatic spurts, and that rates of change haven't always been the same in the past. And sometimes processes have been different, or at least acted at different rates than in the past. So this is thinking about, when we think about paleoclimate and about past atmospheric and oceanic processes and characteristics, we need to think about whether change was all gradual, or whether sometimes changes happened in spurts, so if we can actually detect them in sediments. And also whether the process we observe today, whether we can use to interpret the past. And mostly we probably do. But some processes certainly, or at least at different scales than the other. So these are sort of quite long-held concepts that we still use today. This is just a picture which is a little bit rude, really. It's this child peeing into this river, and it's taking the mickey of James Hutton's, taking the mickey of the catastrophist idea, because sort of debating about whether glacial or fluvial processes shape the environment, and this is arguing that, how could possibly a little tiny stream make a valley, and whether there really has been climatic changes in the past so great that would produce different processes to have shaped that landscape other than fluvial processes. And the basic thing it's just kind of silly.